Hello, class. This is college algebra, and we're going to be doing logarithms right now. And in fact, the written assignment is on logarithms, graphing one of logarithmic function. So this will come in handy for that as well as the future tests. So let's get started. Here is the problem. Graph f of x equals ln of x plus 7 minus 3 in stages. So start with the basic stage and go from there. So by the way, this whole lesson plan here, it's going to be going in this nice little arc, going boom, 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 and then down. It's the order of events, order of things here. Okay, so when we're asked to graph that function right there, we want to do it in stages, and it becomes very manageable to do. So it's an art form. What is the basic function that we can extract from this function right here? Well, I see an ln and I see an x, so it's just going to be this, y equals ln of x. No transformations, that's a basic function. This, by the way, is the same thing as that. So ln is the abbreviation for log base e of x. I almost like this way better because you can see the base right in front of you. Okay. And all basic log functions look like a small r, so that's good to know. So any basic log function is always going to have the x-intercept of 1, 0. It's always going to have a vertical asymptote of x equals 0, and it's going to look like a small r. It's a slow grower. It's an increasing function. As the x's get bigger, the y's get bigger. But it's a slow grower. And that's what an increasing function means. As the x's get bigger, the y's get bigger. Okay, so that's the basic one. That was just have that one memorized. Now, one transformation at a time. I got a horizontal shift and a vertical shift. Whenever given a vertical shift, do that last. You can't go wrong with that. So I'll do the horizontal shift next. Notice it's only one step at a time. So from the basic one, now comes the next one. Notice I included the horizontal shift. What is this graph going to look like? It's going to look remarkably like the prior graph, except we're going to shift it 7 units to the left. Remember, horizontal shifts affect previous x coordinates. And they're tricky. It's the opposite of what you think. It's minus. You go to the left 7, even though that's plus. So notice I just take this original graph and I slide it 7 units to the left. And notice the horizontal shift affects a vertical asymptote. So this vertical asymptote was x equals 0. Isn't that an x right there? And horizontal shifts affect x's. So what's 0 minus 7? Negative 7. So that's where that vertical asymptote comes from. Notice in a vertical asymptote, it's an equation of a line, a vertical line. X equals negative 7. And how do we transform this point here, that x-intercept of 1, 0? We'll get the x coordinate. What's 1 minus 7? Negative 6. And leave the y coordinate the same. So I transformed that ordered pair to negative 6, 0. And that looks pretty good for that second stage. Now for the next stage, which will be the whole enchilada, the whole ball of wax, I'm going to include the vertical shift now. Right here. So there it is. And what is this graph going to look like for this function? It's going to look remarkably like the prior graph, except we're going to drop this graph 3 units downward. Because again, that's what a vertical shift does. It affects the y-axis, or the y-coordinates. So I just quickly drew the graph here. And then more importantly, what's this ordered pair going to transform to? What is this ordered pair going to transform to in the next graph? Well, vertical shift affects y-coordinates. So what's 0 minus 3? Negative 3. So negative 6, negative 3 are this graph has to go through. And then I just drew it. And what's the domain now for this function? Well, the domain remember, domain is super related to vertical asymptotes. So the domain is going to be from negative 7 to infinity, that interval. Rounded parenthesis, because it will never touch that dotted line, x equals negative 7. And notice this part of the graph covers this entire part of the x-axis, so that's why it's to infinity. So that's the domain, or you can write it like this, same thing. Domain is the variable x, so x is greater than negative 7. Isn't that saying the same thing as that? Sure. What's the range for this logarithmic function? And you don't even have to think about it. The range for any log function, whether it's a basic one or one with transformations being applied to it, it's always going to be all real numbers. So that's a good thing to know. What's the range for any logarithmic function? All real numbers. Can't you tell that this graph covers the entire y-axis? This part here is going down, so it's covering the entire negative part of the y-axis. And this is going to the right forever, but it's also going up forever. So it's going to cover this part of the y-axis toward positive infinity. So indeed, the range is all real numbers. Let's find the x-intercept now. We know we got one because I see it crossing the x-axis. So let's do it algebraically. How do you solve for an x-intercept? Always done the same way. You let y equals 0 and solve for x. So that's my first step right here. So again, this was the final function right here. To find the x-intercept, we let y equals 0 and then just write it as is. So we have, for the x-intercept, that. And now the next step, I want to solve for x. Let's make this x term all by itself, isolate it, add 3 to both sides. So now I've got this equivalent equation right here. And it looks tough to solve for this x. How do you solve a log equation? This should be your first thought. Bebop to its equivalent exponential form. So, or just go to its equivalent exponential form. So remember, you can always change the log equation into its equivalent exponential form. And again, that's the best way to solve a log equation, to go to its equivalent exponential form. What's my base going to be for the exponential form? Well, whatever the base of the log is, which is e. So I write e, and then for my exponential form, I need an exponent. We got to remember, logs are equal to the exponent. So 3 is the exponent here. Logs are equal to the exponent. Isn't that where the exponent goes in exponential form? You write it small and high, and then write equals, and then whatever's left, the argument. So these two are equivalent. One's in log form, and one's in exponential form. Notice with the exponential form, you don't see the word log. Okay, now it's looking a lot easier to solve for x. Subtract 7 from both sides, and this is the exact answer. E cubed minus 7 equals x. I used my calculator. I typed in e, and then I cubed it, and then I subtracted 7, and that approximately equals 13.09. That wavy equal sign means approximately equals, because e is an irrational number. This is the exact answer right here, but this is a good approximation, or you can write it as an ordered pair, because this isn't just any x, it's the x-intercept, since we let y equal 0. So there's the ordered pair. And let's make sure our graph does go through. Yeah, that looks like it could be 13.09 roughly. In fact, I actually had to erase my original graph I drew here and make it better, because I trust the algebra. That's the x-intercept. The way I drew it, because all I had was 1 point. I actually had the x-intercept over here, which is wrong. So that's why I adjusted my graph. So now it looks much better. So that is the x-intercept right there, and it is a positive x-intercept, so that's believable indeed. And now let's find the y-intercept. How do you solve for a y-intercept? You let x equals 0 and solve for y. So I'm going to write y equals ln. I let x equals 0 plus 7 minus 3. And let's continue. Next step, y equals ln. Doesn't that argument simplify to 7? 0 plus 7 is 7. Minus 3. Remember, you need these parentheses. This is the argument. That's the vertical shift. Okay, well, in here it's not, I don't know if you'd call it a vertical shift since there's no variable here. Let's add, we want to solve for y. So this is the exact answer right here. ln of 7 is an irrational number, so you can leave it like that. I used my calculator. I typed in what is the ln of 7, then I subtracted 3, and you get this approximation, negative 1.05, or as an ordered pair, it's that. And sure enough, when we look at the graph, doesn't that y-intercept, isn't it negative? That's believable, about negative 1.050, comma, negative 1.05. Okay, so that is that, and goodbye, everybody.